Hey everyone, today we are going to solve the Daily LeetCode challenge of 23 January 2024, and the problem statement is maximum length of concatenated string with unique characters. So let's first understand the problem statement. So according to the problem statement, we have been given an array of strings. And what we have to find is, we have to find the maximum length after concatenating the subsequences of array such that there are no duplicates, right? Now let's first find out that what are the subsequences of this array. So first we can have an empty string, right? After that we can have this CHA, then we can have this CHA and R. So we will have CHAR. Then we can have this CHA, R and ACT. Then we can have CHAR, ACT. And we can have this CHAR, ACT and ERS. Then we can have CHA and this ACT. And again we can have this CHA, ACT and ERS. ACT and ERS. We can have this CHA and ERS only. So we can have this CHA and ERS. Similarly, we can have this R and ACT, R, ACT, this R, ACT and ERS, R, ACT and ERS. Now we can have this R and ERS, R, ERS. Now we can have this ACT. So we will have this ACT. Then we can have ACT and ERS, ACT and ERS. Okay, so these are some of the subsequences that we have got, right? Additionally, we can have this CHA and ERS, like this CHA and ERS, and this ACT and this ERS. And we can have this, similarly, you can write rest of the subsequences as well. Now, let's see, in the question they have mentioned that we have to find the max length after concatenating these subsequences of array such that there are no duplicates, right? Such that there are no duplicates. So let's remove all those subsequences from this which has duplicates. So this doesn't has a duplicate, this doesn't has a duplicate, this has a duplicate. See, A is getting repeated, C is also getting repeated, so let's remove it. Here is also duplicate, remove it, duplicates, remove it, duplicates, remove it. Now here we are not having any duplicates, right? Again we can see that here R is getting repeated, so remove it. R is getting repeated, remove it. This one is fine, this one is also fine, this one is also fine. Okay, now what we have to find is their length. So this is having a length of 0, this is having a length of 3, length of 4. Here we have a length of 6, this has a length of 1, length of 4, 3, 6, 6, and here also it's 6. Now what we have to return is the maximum length. Now what are the max of these values? The max is nothing but 6. Now, so we can see that we can concatenate this ACT and this ERS to get a maximum length of 6. Or what we can do is we can concatenate this CHA and this ERS to get a maximum length of 6, right? This CHA and ERS or this ACT and ERS to get a maximum length of 6. Now I hope the problem statement is clear. So now the question is, how are we going to solve this problem? So if we are given an array of strings, then for each of these values, right? For each of these values, we are having two options. What are those two options? Either I'm going to add this particular value to my subsequence, or I'm not going to add this value to my subsequence, which boils down to take and the not take approach, right? So what we will do, we will make use of recursion. Why? Because whenever we have options, we make use of recursion. So we will use recursion and backtracking to solve this problem. Now let's say if I'm present at any index, let's call it as current index. Okay, and to our subsequence, let's say this is our subsequence using which we are keeping track of whichever strings we have already added. So let's say we have already added CHA to it, right? And let's say we are present at an index, current index. Then what are the options we have? Either I'm going to take the value present at this index, or we are not going to take the value present at this index, right? Let's say in our current index, we have the value as ACT. Now, can we add this ACT to our subsequence? The answer is no. Why? Because you can see that this A is already present in our subsequences. Additionally, this C is also present in our subsequence. And what have they asked? They have asked us for no duplicates, right? They want us unique characters. So we can't add this ACT. So in this case, we won't have a take condition. So what we have to do is, before taking any values, we have to check if it is valid. We have to check if it is valid, if it is valid. Now, what do I mean by checking if it is valid? We have to check whether all the characters of this particular string is present in our subsequence or not. If it is present, then we can't take it. If it is not present, then what it means? All the character of this are unique, means these are not already present in our subsequences. So we can add it to our priorly existing subsequence. Let's say in place of ACT, we have this ERS, right? We have this ERS in our current index. Then can we add this ERS to our subsequences? The answer is yes. Why? Because we'll first check, is this E present in this subsequence? No. Is this R present in this subsequence? No. Is this S present in subsequence? No. So if we will add this ERS to our priorly existing subsequence, then will we have any duplicates? No. So we can easily add it. So before adding any of the strings of this ARR, we have to check if it is valid. If it is valid, then only we can add it. Otherwise, we won't add it. Correct? And once we have taken it, say for example, once I have added this ERS to my subsequence, then what I'll do, I'll simply move to the next index, which would be like moving to the current index plus 1. Correct? Let's do a quick dry run so as to understand this in a better way. So we will start from the 0th index and we will make use of a string. This string will help us to keep track of the length of the current subsequences. Okay. And we will use a hash map. Now, why are we using a hash map? Because we need to keep track of what all characters we have already taken in this string, right? So for keeping track of all the characters that has been used, so as to ignore the duplicates, we are making the use of this hash map. So now I'll check that can I take this value present in my 0th index. So what I'll see, is this C present in my hash map? No. Is this H present in my hash map? No. Is this A present in my hash map? No. So is this valid? Yeah, this is valid. So I can add this. So what I'll do, I'll add this CHA to my current subsequence, right? And I'll move to another index, which is 1. Additionally, what I'll do is I'll add all these characters to my hash map. So I'll add C corresponding to it. I'll add 1, then I'll add H, and I'll add A. Okay. Now I'll check. Can I take this value present at my 1th index? So I'll check, is this valid? So I'll check, is this R already present in my hash map? So R is not present in my hash map. So this is valid. It means I can add it to my subsequence. So I'll take it. So since I have taken it, I'll move to the 2nd index. Now what I have is CHAR. Okay. So up to here, the length was 0. Up to here, the length is 1, 2, 3. Now up till here, the length is 1, 2, 3, 4. Okay. Fine. Now I'll check, can we take the value present at my 2nd index? So I'll check, is this A, but before checking that, we also have to add this R in our hash map. Okay, I forgot to add it. Why? Because we have added this R in my subsequence, so I have to also add it in my hash map. Fine. Now I'll check, can I add this ACT to this CHAR? So I'll check, is this A present in my hash map? So A is already present. So we can't add this ACT to this CHAR. Why? Because if we will add CHAR and ACT, then you can see that A is getting duplicated, C is getting duplicated, and we should not have duplications, right? So now you must have understood why we are making use of a hash map. So we can't use the value present at my 2nd index. So what I'll do, I'll move to the element present at my 3rd index. So I have come here at the 3rd index, and up till now I have CHAR, right? Now I'll see, can I add this to my priorly existing subsequences? So let's see, can we add this E? So E is not present in hash map, right? Now we'll check, is this R present? So R is present in our hash map. So we can't add this ERS to CHAR, correct? Now what we'll do, we'll move forward. So we have come to the 4th index and the 4th index doesn't exist. So what we'll do, we'll backtrack. So while backtracking, what we'll do, first we will remove the element which we have taken. So we have taken the element of my 1th index, right? You must have seen that this 1th index element we have taken. So what we'll do, simply we'll return from here, and while returning from this place, what we'll do, we'll remove this R. And after removing this R, we will also remove it from our hash map. So we'll turn its frequency to 0. Now we have CHA as our subsequence. Now since we added the 1th index, now what we will do, we will try to add the element at our 2nd index, right? So we will have here 2 and we will have CHA. Okay. Now can we add this ACT? So we'll check, is this A present in our hash map? So A is already present in our hash map. So we can't add this. So we will have another branch, right? We'll move to the 3rd index. Now we had CHA, right? We had this CHA. Now we'll see, can we add this ERS? So we will see that E is not present in hash map, R is not present in our hash map, S is also not present in our hash map, right? So what we will do, we will add it. So we added it. So we'll move forward to the 4th index. We have CHAERS. And what is the max length that we have got? The max length is now 6. So the max length is 6. Okay. Now, since we'll again move forward and we'll see that we have completely exhausted the array. So now we don't have any more strings to add to our subsequence. So we will backtrack. So what was the element that we previously added? We added the element present in our third index, which was ERS. So what we will do, we will remove this ERS and and we have to do one more thing is like the moment we added this ERS, we have to also add this to our hash map, right? So we will have one corresponding to E, then corresponding to R, it will again turn to 1. And for S, we'll have 1. Now, while backtracking, what we have to do, we have to remove this element present in our third index. So we will remove this ERS. And additionally, we will turn this 1 to 0, this 1 to 0, and this to 0. Okay. So we will come here. Okay. Now what we'll do, we have explored all the possibility that we can have with the 0th index. Now we will backtrack this as well. So we will remove this CHA, that is the element present in our 0th index, and we will turn its frequencies to 0 as well. And we will return over here. Okay. And up till now, we have got 6 as the max length. Now we will start from the 1th index. So again, you can draw the recursive tree on your own. So again, at 1th index, what you'll have? You'll have an empty string. And you can see that all the values in the hash map are 0. So it represents that it is simply empty. So let me erase this. Okay. Now what you can have? Now you'll check, can you take the value present in your 1th index? So yes, you can take it. Why? Because your subsequence is empty till now. So if you take it, you'll move to the 2nd index, you have R. And what you'll do, you'll add this R to your hash map. Now you'll check that, can you take the value presented in your 2nd index? So you'll check, is A present in hash map? No. Is C present in hash map? No. Is 1 present in hash map? Sorry, is T present in hash map? No. So you can take this, right? So if you'll take this, you'll move to the 3rd index, and what you have R, A, C, T. Fine. And you'll add this ACT to hash map. So it will have A, C, and T. Now, over here, you had a length of 1. Over here, you have a length of 4. And what is the max of 6 and 1? It's nothing but 6. Now, what is the max of 6 and 4? It's nothing but 6. So the max length won't get updated. Now, you'll move to the 3rd index. So in the 3rd index, can you add this ERS? So we'll check, is E present in hash map? No. Is R present in hash map? So you can see that R is already present. So you can't add this ERS to RACT, right? So again, you have exhausted the array. Now again, what you'll do, again, you will backtrack. So since you added the element present in the second index, right? This 2nd index element you added, which is ACT. So while backtracking, what you'll do, you'll remove this ACT, and additionally, you will turn this to 0, this one to 0, and this one to 0. And you'll backtrack. And again, you'll explore other possibilities, which is taking the element present in my 4th index, right? And similarly, you can draw the complete recursive tree, and you'll find the max length is nothing but 6. Now, let's quickly code this without wasting any further time. So we'll start on by initializing a variable called max length. Initially, its value would be 0, and we'll use this max length to keep track of the maximum length that we have got up till now, right? Additionally, we will need a string. Like I have shown you over here that we are using a string to keep track of the subsequences. So let's name it as current, and it would be initially empty. And we'll need an unordered map, right? It would be of type character comma int. Why? Because here you can see that we are using a hash map to keep track of whatever characters we have used, right? And let's name it as demo. Now what we'll do, we'll call a function, let's say find max length, and we'll pass on the current index. We'll be starting from the 0th index. We'll pass on this current, we'll pass this max length, hash map, and the vector which is given to us. And finally, we'll return the max length. Now let's complete this function find max length. So it would be a void function. It would take current index and a string to keep track of the elements of the subsequence. Then we will have this max length, which is an integer to keep track of the maximum length we have got up till now. We will have this unordered map of character and int. And we'll pass on the vector of string, which was given to us in the problem. ARR. Now, if our current index becomes equals to the size of the given array, so it means that we have completely exhausted this particular array. So what we have to do, we will simply return from over here, right? We'll simply return. Otherwise, what we will do, we will explore all the possibilities. Now, what do I mean by possibilities? We'll start from index equal to current index. And we will go up till it's less than the size of the array. Okay. So here you can see that first I was taking the first index, then if it wasn't valid, I moved on to the second index. If it wasn't valid, I moved on to the third index. Right. Now what I'll get a string. Let's call it as current string. And this is nothing but this is the value present at my index. Right. Now I need to check if this is valid. If my current string is valid. Now, what do I mean by if my current string is valid? It means that if the characters of my current string is not already present in this current, right? Then only we will add this current string to this current. Okay. So only if this is valid, what I'll do, I'll add its character to current. Additionally, what else I have to do is I have to add those characters to this hash map as well. So let's take I as 0 and let's have a while loop over here. So I'll say while I is less than current string dot size. What I'll do, I'll say that current dot pushback, current string of I. And I also need to add it to our hash map. So I'll say that hash map, add this current string of I to the hash map. Fine. Now what I did is I added all its character to my current subsequence. And after that, I added all its character to our hash map. Fine. Now, since we have got a valid string, what I'll do, I'll simply add it and I'll move to another index. So here I'll have a recursive call, find max length, and I'll move to index +1. And I'll have current over here and max length, memo, and ARR. Fine. Now, what we were doing over here, you can see that we added this RACT, right? Now, once we completely exhausted, after that, what we were doing, we were backtracking. That is, we were removing this ACT first from our subsequence. And after that, we were removing its occurrences from the hash map as well. So once we have made a recursive call, what we have to do is we have to undo the changes. Undo changes. Now, what all changes we made it? We have added it to current, right? So we have to remove it from current. Additionally, what we have to do is we have to remove its occurrences from the hash map as well. Sorry, it would be I++ over here, right? So what we'll do, we'll set I as the length of the current string. And while we have this I, what we will do, we will say current dot popback, right? And after that, I have to remove its occurrences from hash map as well. So I'll say that memo of current string of I minus minus. Fine. And from here, we'll simply return. Now, one thing we are missing, and what's that? At each step, we will be calculating the max length. So we will write over here, max length is equal to max of max length and the current length. Current length is what? It's current dot size, right? So let's take this out over here. Let's say int length is equal to current dot size, and we can write it like this as well. Yeah. So yeah, we have to now complete this is valid function, right? So let's write it over here. So it would be a Boolean function. It would return either true or false. It's taking this string, current string as input. So it would be current string. And additionally, we need this hash map as well, right? Let's see over here. So what we were doing is, say, for example, I want to add this ACT to my subsequences. So for checking if this is valid or not, what we were doing is we were iterating over each of its character and we were checking if it is present in our hash map or not, right? So we will also need to pass this hash map over here. So we'll pass this memo. So we have to write unordered map of character comma int, and this is memo. So what we'll do, I'll iterate over this hash map. So I'll say for auto current character of my current string, what I'll do, I'll check if this current character is already present in my hash map, then I'll return a false. Why? Because say for example, I have a character like A and A is already present in my hash map and I have got a string which contains A again. So can I add this string to my already existing subsequence? The answer is no. Why? Because since in the already existing subsequences, I had A and in this I also have a A. So if I'll add it, then A will get duplicated and we don't want any duplication, right? We want only unique characters. So we'll simply return a false. Otherwise, what we will do, if we don't get any duplication, we'll return a true. Okay. Now, one more thing I'd like to mention, and it's, let's say if we have a case as AA. right? Now you can see that when we'll process this AA, at that time my hash map would be empty, correct? I won't have any element in my hash map. Now I'll check, can I add this AA to my already existing subsequence or not? So I'll see that this A is not present in hash map and this A is also not present in my hash map. So this will return a true. But is this correct? The answer is no. Why? Because it is already having a duplicate character. So for keeping track of these cases, what we will do is we'll take an unordered map over here of character comma int. Let's call it as temp. And what we will do, each time we will say temp of current character plus plus. And we'll say that if we have temp of current character such that it's greater than 1. So it means what does it mean that it's greater than 1? Let's say we have this A, we have added this A to our temp, and again we have met this A. So in this case, what would be its frequency? It would become 2, right? I'm sorry, this would be over here, right? So its frequency will become 2 by that time, and it means it's getting duplicated, right? So in that case as well, we'll return a false. Now let's quickly run our test case. So it's giving us the correct answer. Let's submit it. So it got accepted. Now talking about the time complexity and the space complexity. So the time complexity would be 2 to the power n, where n is the length of the given array. Why? Because for each of these strings, right, present in my ARR, I have two options, whether to take it in the subsequence or not to take it in our subsequence, right? And the space complexity is order of n. Why? Because we have used this hash map to keep track of all the characters which we have already added to our subsequence. So that's all about today's daily LeetCode challenge. Thank you.